Hello everyone and welcome to the first episode of the Tiny build series. As you can see, I have a lot of the metal parts here, so the most of the panels, about 2/3 of them, the aluminum extrusions and the bed. So aluminum extrusions and the bed, obviously all of them are here. With the panels, I didn't order all of them. I'll get to the reason of that, but I want to start with the bed. So this is a 150 by 150 bed, 60mm thickness. 6 might seem a bit thin, but at the same time the Voron Zero, the Mandala Roseworks bed on that is 6mm thick, so that's fine. So if 120 is fine, 150 should be fine as well. And I wanted to make sure this was relatively thin so it heats up quicker than my Voron 2. This is also flattened on the surface, so it should be really flat, but obviously we'll see when we install it on the printer, but I'm assuming it is. All of the extrusions, as I said, are here as well. Well, hopefully I didn't forget any of them. And as I said, with this build I'm going with silver extrusions, so no painting these this time. But yeah, they look pretty nice, and some of them are a little scratch from shipping. They didn't wrap all of them in this material, whatever you call it, but they will be mostly covered by the panels as well, so that's not a huge deal. And as I said, a lot of the panels are here as well. I ordered about 2/3 of them. I didn't order all of them, just so this is the first time I'm using this company, and well, I didn't want to risk it. But anything below 2/3 of the panels, then I wouldn't have enough to build as quickly as I want to, so it would slow down progress. But turns out they are pretty decent, and you can see that with the aluminum ones, at least there are pretty weird shapes like this one. So yeah, I think they turned out pretty nice, so I'm happy with that. The black steel panels, on the other hand, the cuts are pretty nice, but I don't know about this residue on this. It's, I guess, some sort of cutting fluid or something, just to keep the steel cool. That's what I'm assuming. I don't know for sure, but yeah, hopefully whatever that is, that comes off with water, isopropyl alcohol, something like that. I'll try a few things. If they come out, these look pretty nice as well, but with those, obviously they don't look that great. And the reason this is separate is both the aluminum panels and the steel panels that I showed here are 2mm thick, as I explained in the CAD. This is 5mm thick. This is the bottom panel, and it is pretty heavy, and that is by design. I wanted to keep the center of gravity low, so I don't know, maybe it will matter, maybe it won't, but honestly it doesn't really matter. I just wanted the weight on the bottom, so yeah, that's why that is thicker. All of the other panels, including the ones that I'm going to order, are 2mm thick, but yeah, before that we will obviously do a decent amount of the build, and then we'll get to that probably in the next episode or sometime after that. I still don't know what this stuff is. The brownish rusty looking parts, they do come off, so I don't think this is rust, but still I don't know what it is. And I tried removing it, and as I said, I can get rid of the color, but the wavy marks, they still stay on the steel, so it still doesn't look that great. I tried isopropyl alcohol, I tried acetone, I even tried paint thinner, and nothing really seems to work. So yeah, whatever this is not coming off, it's on the steel. So since this doesn't look that great, well, I do need a different solution. Well, my first instinct was getting them spray painted. I still have a bunch of spray paint lying around, but I don't think that will look that great, and I know how easily that is scratched. So I continued thinking, and I decided to use matte black vinyl thing that you use on cars and whatever. And yeah, this looks pretty decent, but I'm not great at applying this, so there will be some bubbles here and there, and I'll try to get rid of them, but it won't be perfect for sure. But that still beats looking like this, so yeah, I think that's what I'm going with. So I'm going to cover all the black steel panels with this stuff, and I think it will look pretty decent. I also did the electronics panel on this side, so I'm going with a 350 watt meanwhile power supply, the Big 3 Tech SKR Mini E3 V2.0, and here I have a buck converter, but I think I'm going to replace this with something else. I'll get to that. But yeah, this is for the 5-volt supply for the Raspberry Pi, which will sit here. I thought I had Raspberry Pis lying around, so I didn't order one, but Well, I'm sure I do, but I can't find any, so I'll order one and I'll place it there whenever I receive it. But this is basically the entirety of the electronics. I want a DC bed, not because of any safety concerns, but just so I don't have to deal with an SSR. I think it will heat pretty well, and that's why I went with a 350 watt power supply. It should do the job. Eventually, I might consider a chamber heater, and if I do that, well, that will probably be AC, and in that case, I will probably need an SSR somewhere, but yeah, for now I think this will do. So that's why I went with this setup, and I think it will work pretty well. So as I said, I'm just waiting for the Raspberry Pi, and here I have a custom PCB design that I'm going to get to, well, now. This is the PCB that I was thinking about showing you at the time of recording that, and well, I might still go with this, but I do also have another revision that I'm considering. But yeah, let me just go through the features of this. So this has a few things built in. It has 5 volt and 12 volt buck converters built in, so that means this generates a 5 volt and a 12 volt rail, which means you can power your Raspberry Pi and 12 volt fans through this. And kind of like the spider board on my Boron 2, you can see the voltage selectors for the fans here. So you just connect this to the Big 3 Tech SKR E3 Mini V2.0 and select the voltage for the fan here using jumpers, and there we go, you can just connect the fan directly here. It's just a quality of life thing. Obviously you can edit your cable and plug it in different places to get the different voltages, but it's a quality of life thing since I also have this built into this board. It also has 2 mounting locations for Max31865 boards. My TinyM build, I want it to be high temperature capable, which means I can't just use a thermistor on the hot end. I need to use something better. So I think I'm just going to use a PT100 like usual, like I did on my Boron 2. And for that, you do need a board to actually read it properly. So yeah, you need a Max31865 basically, or the E3D style amplifier, but this is better in my opinion. And I have 2 so that I can connect one to the bed if I want to. That one isn't really necessary, it's just, since I have the space anyway, I might as well build it in, and I don't know, maybe I'll use it someday. You'll also see the ton of pin headers on the side. That's the side with the Raspberry Pi. So this is actually also a breakout for the Raspberry Pi's GPIO. You connect it through here and it powers your Raspberry Pi using its 5 volt buck converter, so you don't need a separate buck converter or a power supply rail or anything like that. It's just all integrated to this board. And it also provides the breakout, as I said, so you can see the GPIO pins on the bottom, and I2C, UART, and SPI buses. The Max31865 also run on that SPI bus, so they're shared, and that SPI bus is, as I said, connect to the Raspberry Pi, and I've been using that setup on my Boron 2 for many months now, so I know it works, but there were also some bugs with it that hopefully will get fixed eventually. But yeah, as I said, I know it works as long as you set up the Raspberry Pi to use the Raspberry Pi MCU. And yeah, that's the design I had here. Oh, and one more thing, the power outputs, so 24 volt, 12 volt, 5 volt and 3.3 volt are all here, and you connect 24 volt here, and it obviously creates the other rails. As I said, this was the design I had in mind when I was recording that, but I also have a new design for this, and it's this. And you'll see that it doesn't have the same buck converter modules on it anymore. The thing with these modules are, A, they are pretty expensive, and B, they can be difficult to get. By the time since that I designed this board, one of them, I think the 5 volt one, went out of stock. So, I don't really want to risk it. So I came up with a new approach, which actually is just having the components assembled on a board. So this module, this actually uses the same components at least for the, the main converters as the spider board. So it generates 12 volts, 5 volts, and 3.3 volts on board. I don't think I'm going to use 3.3 volts, but I kind of wanted this to be generic, so if I want to use this for a 3.3 volt build at some point, or if I have a need for that, it could be built in. So yeah, this is basically that. It, as I said, uses the same stuff, but the rest of the components, some of them are swapped out. Now, I really am not experienced in electronics design at all. I basically did the ADXL345 MCU, and that's about it. So
I don't know how well this is going to work, and that's why I'm debating whether I should just select a different buck converter for this or try this. And yeah, all of these components are available on JLC PCB, so I can get this assembled relatively easily. But yeah, I don't know. I'm thinking about it. But if I'm using this module, uh, this is the PCB that I have. So in this case, it mounts on the back, and on the front, again, the GPIO breakout, 24-volt input, the buses here, and the fans here, and power GPIO. The same feature set. Is just a smaller board, and the power stuff is mounted on the back. I could also move it to the front so it gets better cooling. I don't know right now, just thinking with some ideas, but the thing I can say for sure is I will definitely have a custom PCB there. I want the 12 volt and the 5 volt rails, and well, that's really the only thing I care about. The rest are just for for quality of life, nothing really that important, but I do want rails. So yeah, stay tuned for that. I guess today I'm not going to order anything, but eventually I will, and well, you'll see it in a later episode, I guess. And there are some minor changes to the CAD since the video I made about this, so yeah, I'll just go over them. So in the back you'll notice that there is now a fan here. Now as I said, there is a decent amount of insulation between the chamber and the electronics area, so that fan is just for cooling the electronics. So yeah, don't worry about it cooling the electronics. That's not going to be cooling the chamber, sorry, that's not going to be an issue, and it will help me cool down the electronics, because otherwise this is a pre-enclosed setup, and yeah, I'd like to be sure that these are actually kept cool. And you can also see the board that I just showed you in Easy EDA, so it will fit in here. There shouldn't be any problems. This is a new feature of Easy EDA. You couldn't export stuff as 3D objects before. Now you can export them as OBJ files. I still prefer step files, but this is better than nothing. And yeah, those are some changes. Also, you'll also see the keystone here. So I want to have Ethernet on the back. The reason for that is, well, I'm happy with the Wi-Fi setup that I have on my current printers, but the thing is, the Raspberry Pi in this case will be enclosed and it will be surrounded by metal, so it could act as a Faraday cage. So having a Ethernet on the back could save me. Otherwise I'd have to figure out a way to route the Wi-Fi antenna somehow, and I don't even know if it's technically possible with the Raspberry Pi or not, but just having an Ethernet is fine, good enough. And yeah, if I have to use this, I can just use a switch somewhere and then it will do the job. So yeah, that will work. In the front you'll see a NeoPixel stick here. The NeoPixel stick has 8 NeoPixels on it, so it can act as a progress bar. I talked about this in a really old War on 2 episode for the first revision of my toolhead boards. I basically had the kit lights on the toolhead board, and I never actually ended up using it, and then switched to the second revision, so that never really happened. I wanted to do that for my War on Zero, but I just never got around to doing it. It was basically the same design, and I actually have the part printed even, but yeah, just never ended up actually doing it. For this printer, I want to do it, but yeah, who knows, maybe I'll change my mind, I still don't know. As for the printed parts, I still haven't decided what I'm going to do, but yeah, I'm sure I'll address that later in this video as well.
It's been some time since the last recording and I got my War on 2 working, so I printed the drill guides that I designed, except one of them, the one labeled C here, that's for the bed extrusions. I just designed that, that's why it's not printed. But they're all printed and I used them to drill the extrusions, I'll get to that. But I also noticed that I forgot to order the 130mm extrusions for the bed, so I have to place yet another order. But that shouldn't delay today's episode anyway, and I'll do that eventually when I receive the parts. So here we can see the bed. I drilled this using the usual Voron style, so 3.5mm drill bit for the M3 screw, and then a 6mm drill bit, if I remember correctly, so that the head of the M3 screw is countersunk, like this. You can see the head of the M3 socketed screw doesn't stick above the surface, which is what we need. So yeah, this turned out pretty well. And I also drilled the extrusions that need drilling. So the top two ones, these are for the door. The rest are the sides of the printer. So all the drilling is done. And I also tapped every single extrusion that I have, even though not all of them need tapping, but most of them do. So I just tapped them all, and so they all have an M6 thread in the end of each extrusion as well. So we can actually get to building the printer. So yeah, let's just start with the frame. I assembled the frame, at least most of it, and well, this is how it looks. I just mounted the base plate, didn't do any of the rest of the panels, and this is the front view, and from the sides it's like this. I already showed this in the CAD, so I'm not going to spend too much time on this, but you can check the CAD out if you want. It's even on GitHub if you want. But this is the front, and between this extrusion and the one on the top, that's where the door is going to sit. But you'll realize that I don't have all of the extrusions on there. First of all, these four, those are for the door, so yeah, that they have to wait a bit. But these four, it's me being an idiot again, and forgot to prepare one more drill guide, which actually was supposed to be used for drilling these bottom and these top extrusions, well, middle I guess. And that's where you sit the Z-axis with the lead screw and MGN 12 rails. But it's mostly ready, and just for scale, this is how big the bed is. It is a lot larger than the bed, as you can see, but that is something we already knew about this. It's just that, you know, seeing it in person makes a difference. But yeah, that just shows you how much insulation I'm going to get on this, so I think it will work pretty well. So yeah, I guess I'll get to working on the drill guides for these, and once I print them I'll have to disassemble this whole thing and then drill them and mount them.
Well, I'm an idiot. Basically, I got the positions of these extrusions wrong, and that means I got the drill guide wrong, and I noticed that while I was working on another drill guide. So yeah, that's just great. I'll have to drill more holes on that, and I think I got the position of this extrusion wrong as well, so again, I'll have to fix that. There will be more holes in these extrusions, but well, at least that doesn't really matter because the panels will cover the extrusions, so it's not going to be visible, but you know, it's still not great. But yeah, I started working on a new drill guide, and I'm actually unifying all three drill guides that I designed into a single design. So yeah, this should make life easier. It should be a single print, and I'm also creating documentation for the drilling of the extrusions. So in case you want to replicate my design, or you know, do your own, this should make your life easier as well. And this will be available on GitHub on here. So as I showed this before, this project is already on GitHub, and everything I have designed is already here. Looks like I updated this last 2 weeks ago, but you know, the updates are coming to this fairly often since the creation of this repository, and I will update this pretty soon as well with new things I have. But yeah, I have to double check if this guide this time is correct or not, and I'll have to redrill the extrusion here. As I said, they're not going to be visible though. And yeah, that's one thing. You'll also see the PCB LGX extruder here with a modified tool head. I know this is ugly, but the thing is, I'm just trying some ideas here. I don't know if I'm actually going to go with a BMG extruder or not, but this is just something I had in mind, and yeah, I'll think about it. Now, the thing I want to actually talk about is the material that I'm going to print the printed parts out of for the build. So I don't want to use ABS, is basically what the problem is. ABS works great for most Vorons, and even on my Voron 2 I'm sure it will work pretty well, even with the Doom Cube insulation. It's just a great material for many things, but if you want a high temperature capable printer, ABS isn't great, especially above I don't know, 60, 70, maybe 80 degrees chamber temperature. It just doesn't work very well. So there are some materials that a few people tried, like cf-nylon and stuff like that. But for example, CNC Kitchen Stefan, he built his Voron Zero using cf-nylon, and they all bent like crazy due to heat creep. So it's not really, there really isn't a great tested and well-known material for printing the parts for high temperature builds, so I'll have to think about it. One material that I heard people say works well is cf-nylon that's made by 3DX Tech. It's this high temperature cf-nylon, and I've heard people had good luck with this, but it's also still pretty expensive, and I don't know how well it will work, and I don't know if I can actually print this on my warranty or not, so yeah, I don't really know. Another option is going with MJF printed parts. That will be even more expensive than this though, and I don't really want to spend that much, to be honest, so I don't know. I'm thinking about it. If you have any materials you have in mind, you can leave them in the comments down below, but I don't know. I'm thinking about it. As I said, I want this to be a high temperature printer, even though I have no use for one, so I'll think about it. I'll try to come up with something. But that's it for this video. I hope you enjoyed it. If you did, please leave me a like down below and stay tuned for the next episodes if you're interested in this build. And that's it. Thanks for watching.